Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 25, 2025, about 2 days ago. The headline result is a training-free method that prunes vision tokens using multimodal coverage, delivering a 1.87 times speedup on the POPE dataset, while maintaining 98.7% of the original performance on VLM XT13B. The paper is titled MMTok, Multimodal Coverage Maximization for Efficient Inference of VLMs, and as we'll see later, the efficiency gains come without sacrificing much accuracy. In short, the approach selects vision tokens by covering both text semantics and visual redundancy, and it even works with as few as 4 vision tokens on LAVA 1.57b, preserving 87.7%. Alright, the introduction just set up the token redundancy problem. Figure 1 shows how performance holds up as vision tokens are pruned, and how methods compare across model families. The left panels plot performance preservation against token budgets, which highlights that the multimodal coverage approach stays near 90% down to modest budgets, while unimodal baselines drop sharply. The radar chart on the right summarizes cross-architecture results, showing consistently higher preserved scores and a clear margin over prior pruning strategies. So Figure 2 explains how the method actually runs. Figure 2 shows a pipeline where the vision encoder emits many vision tokens, and the tokenizer supplies text tokens, which then feed a multimodal coverage selection block. The block scores text to vision and vision to vision similarities, and a greedy search picks a compact subset that best covers both, so the final sequence sent to the vision large language model is much shorter. An optional lightweight agent enriches the text tokens, which sharpens the selection without extra training. Okay. The last figure outlined the pipeline. Table 2 presents head-to-head results across LAVA 1.5 and LAVA XT, showing preserved performance at different token budgets. MMTok consistently leads, keeping about 98 to 96%, as tokens drop from 192 to 64, and it still wins on the larger XT models at tight caps like 160 tokens. The agent variant adds small gains, which makes sense because better textual hints guide selection without retraining. Alright, Table 1 reports LAVA 1.57b across 9 datasets at 3 token budgets, so it directly shows how pruning affects accuracy. The key pattern is consistent. MMTok tops non-fine-tuned baselines at 192, 128, and 64 tokens, preserving about 98.7, 97.9, and 96.5% respectively. The agent variant edges slightly higher at the larger budgets, which suggests richer text guidance helps selection without retraining. Wrapping up, 2 takeaways stand out. Multimodal coverage, not unimodal pruning, is the key lever for efficient vision language model inference, and a simple greedy selection grounded in maximum coverage yields real wins, like 1.87 times speedups with minimal accuracy loss. The broader implication is practical deployment. Fewer tokens, lower memory, similar quality. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.